Okay, so this week I've got two fabricators that are capable of doing the job. I'm pretty sure that I've chosen one. I've just got to do one more drawing for them, send that off to them on Monday, and then I'm going to get the order placed on Monday. So it's been a little bit of a setback. In the meantime, I'm going to modify this. This extraction system that I made, kind of. And I had this sort of handle thing, and it's got this big long hose that it came with, and then I made this kind of thing which was supposed to sort of be able to move the hose around and balance as to where I wanted it. So I've got those counterweights on the end, but it never really worked very well. It was sort of a cheap version of one of the professional ones that you can buy, which have got like a concertina thing. So I'm going to do away with it. I'm going to take it off, and I'm going to fit all this lot that I've bought into a new welding extraction system in both rooms now. I mean, I know it's not very interesting and everybody wants to see the submarine, but unfortunately it's a 5-week delivery time, so this will have to do. And hey, it's kind of related, you know. It's for the submarine mostly. Oh, someone didn't like that. It's all right. It's all right. Wasn't that bad. It's only a bit of pipe. Well, that took a little bit longer than I expected, but it's turned out actually okay. So we've got a valve here so I can switch this one on and off. So, I mean, it's just the same sort of trunk system, except it's not as long and I haven't got that thing. So I'm going to make something to hook this up out the way. And I've got a nozzle for the end, but I think it might be in the car. And then at this end, same sort of thing. So I can switch this one on and off. So I switch that other one off and this one on. That means this one's on. And realistically, that's probably where the sucker needs to be. But I can move it about. That's about it. Don't worry, it's CAD Sunday tomorrow. Highlight of the week.
Today is I wanted to verify that the underwater stability is going to be correct, and I've done this before but wanted to double check it. So I've got my mass calculation here, which is as accurate as I can be. Not 100% sure what's going to be in the boat, but that's as accurate as I can get. So that gives me my center of gravity there, and I'm just going to do a sketch on this plane here, and I'm going to draw a line from the center, and then I'm going to zoom right in, get it reasonably accurate, and put a dimension on that, and that is, what is that, 50.02, so we'll just say it's 50. Okay, so we've got a center of gravity 50 millimeters down from the center line. Now, I know that previously I've done my volume. Now, I know I've got my my volume, which I did last week, to give me a sort of rough idea of displacement, which is reasonably accurate. But what I've done now is I've done a better one, and it's taken quite a while to do this with the dreaded boundary fills, but this is completely solid and everything's made out of water. So anything where I'm underwater, this is going to be in the underwater state. Anything underwater where it's going to contain air or be solid is water. So this is going to provide me with a much more accurate displacement. You can see there. Now, if I do properties of this, it'll take a while to calculate this, I think. These viewports are still made out of steel because they're linked, and I can't unlink them because it doesn't recompute the model properly. So I need to just redo that. So there is going to be a little bit that's not quite right, but it's only a bit. So we got 1.358 times 10 to the 9. So let's just quickly do that. 1.358 10 to the 9 divided by 1,000 squared equals 1358 litres of displacement, which is not far off 1358. Oh, come on. That's not far off my volume. And that extra bit is going to be taken into account for all these other little bits and bobs, which although they're solid and obviously they'll sink, they are providing a buoyant force. Anyway, right, from this I can work out my centre of buoyancy more accurately. So this is just a centre of mass of this whole thing. And now if I do the same as we did earlier, I do a sketch on this one, do a line, my centre line, and I'll zoom right in there, and then dimension that, and that is a bit difficult to see. Oh, 52. Okay, and I'm going to do another line now. I'm going to do this, dimension this to be 50, which was where my center of gravity was. So my center of buoyancy is there, center of gravity is here. Let's scroll out so we can finish that sketch. So that was 50 and 52 and 50. So I've got a GB of 102 millimeters. Now, looking at the ABS rules, if I go to page 115 here somewhere, maybe it's 116 there. Underwater operation, central buoyancy is to be above the center of gravity by a distance GB, which is greater than 51 millimeters or as determined below. Now this calculation takes into account loading and people moving around and stuff, which isn't going to be relevant to me. So long as it's 51 millimeters, and we know that we've got a GB of 102 millimeters, so I'm happy that it's going to be good and stable underwater. I do want to just recalculate this waterline because it just seems a little bit excessively high, but I have done it again and it does seem to be right. I think it might be these tanks are providing buoyancy, so they're not going to provide stability, but they will provide buoyancy, so they are pushing it up, providing a buoyant force. I'm not sure whether I should just leave them there, move them up, or do away with them altogether. Anyway,